Good morning, Putala. Okay, 2 more papers, and 2 more days. You guys gonna be with me. Actually, I thought of going on up to this end of this month, but then I thought I need to do this 2022 paper a little ahead of time so that you guys can get this your own assessment and everything. Then I would make a little. Maybe together with 2022 or after that next week, I'm going to make this my last, whatever these advices to you guys, how you guys going to prepare and how you're going to make your mind and, everything that you're supposed to bring to this exam hall and all those, just to explain everything. Anyways, officially we have only 2 days to do this past papers, because we have only papers up to 2022. So have this confidence, you guys have done everything and came all the way from the beginning, and now you are here doing everything together with me. So have the confidence that you can do this, you are in the right path. Actually, you are in the right path, because now whenever you are sending me marks, and Damsi Vihas and this Tasindu, they are not sending me. Even I don't know, Liana, maybe she is doing this. Or Joanna, you are also not sending me these marks. So I can guide you for the rest of these parts that you have missed. If you have little issues, like, the repetitively, if you are doing same mistakes, so I have some advices to give you guys, these hints, okay? So other than that, students who's sending me marks, all these Columbus students, I mean, and Ratnapur, only couple of students are like hanging in up to the last thing. So they are having this good, like reaching almost 50. It doesn't matter, but I just want you guys to go above 40. At the same time, give the same attention, pay the same attention to structured essay analysis. If you are doing that exactly correctly, then this part is very, very promising that you have an A pass. And if you follow all my rules, then a good super A is there waiting for you. So you are out of danger of having B pass. You are in, actually you are at the level of A pass. Just need to make sure that it's increasing is Z score whenever you are increasing your marks on chemistry. So try to reaching the 100 is our target. I have forgotten, usually I don't refresh my knowledge for these papers, but I have forgotten this 2021 answers, because I did this only for 2000 students, 2022 students, that's only the last year. I just refreshed, but let's see. Question number 1, answer 4, 2, answer 5, 3, answer 2, 4, answer 4, 5, answer 1, 2, 5, 2, 6, answer 3, 7, answer 4, 8, answer 5, 9, answer 3, 10, answer 5, 11, answer 3, 12, answer 2, 13, answer 5, 14, answer 4, 15, answer 5, 16, answer 2, 17, answer 2, 18, answer 5, 19, answer 3, 20, answer 5, 21, answer 4, 22, answer 4, 23, answer 5, 24, answer 1, 25, answer 1, 26, answer 4, 27, answer 3, 28, answer 3, 29, 2 answers, 3 and 4, 30, answer 2, 31, answer 4, 32, answer 4, 33, answer 2, 34, answer 3, 35, answer 5, 36, answer 4, 37, answer 1, 38, answer 5, 39, answer 5, 40, answer 2, 41, answer 1, 42, answer 1, 43, answer 2. 44, answer 5. 46, 45. 45, answer 1. 46, answer 4. 47, answer 1. 48, 2 answers, 1 and 4. 49, answer 1. 50, answer 3. Select the correct statement with regard to, let's go with MCQs. Question number 1. Select the correct statement with regard to particles associated with cathode rays. You guys know all these answers. The particles are uncharged. No, those are negatively charged electrons. They travel from cathode to anode. Second one is wrong. Third one, the charge to mass ratio does not depend on whatever the gas. Third one wrong. They have the ability of ionizing gases. That's how actually they are making these canal rays. Their direction of travel is affected by magnetic and electric fields. That is the correct answer because they have this negative charge. So that question number 1, answer 4. Question number 2, which of the following statement is incorrect? Principal quantum number equals to 2. Principal quantum number equals number of subshells. So 3, n equals to 3 means there are 3 subshells. Orbitals, number of orbitals equals n squared. So it's 9, or otherwise you can go with SPD. 1, 3, and 5, so it's 9. Number of electrons, each has 2, multiplied by 2, that is 18. There are a lot of different methods. Maximum of 10 electrons is angular momentum, azimuthal quantum number L equals to 2. L equals to 2 mean D that has 10 electrons. Otherwise, you can go 2 equals 2 into 2L plus 1. N equals to 3 and ML equals to 0. Magnetic quantum number. S has 0, P has 0, 2 has, D has 0. Each has 2 electrons, so it's supposed to be 6, not 8. So that's why it's wrong. So not 8, it's supposed to be 6. Question number 2, answer 5. Question number 3. Decreasing order of first ionization energy. See, that's why you got to concentrate on this hydrogen and helium too. So goes hydrogen and helium this way. Hydrogen in the middle and helium is up above than neon. So then question number 4, 3, if you go with all these, answer 2. Question number 4, there are shapes. So these 3 shapes are seesaw, square planar, and square pyramidal. Question number 4, answer 1. Question number 5, answer 2. Question number 6. They are going with this intermolecular interactions. Suji. Question number 6. Nitrogen non-polar. Ammonia has hydrogen bonds. So the next one, molar mass of this 3-carbon hydroxyl group is greater. Fifth one, when the surface area increasing, molar mass, the boiling points are higher. So we can only consider the sixth one going down the group, molar mass is increasing. Question number 6, answer 3. Question number 7. Guys, just give me a second. Question number 7. MOH is a sparing soluble solid. Concentration of M2 plus aqueous in the saturated solution is at 8 pH at a given temperature is given. Okay, so that we can calculate this KSP from that. Given that OH minus concentration, the pH of the saturated solution they are asking when M2 plus concentration is changing. Okay, so the initial part, pH equals to 8, so that POH equals to 6, so that OH minus concentration become 10 to the power minus 6. That actually is the total OH minus concentration. So 2 mean you don't have to multiply by 2 because the total OH minus is this. Then as a data, they were given M2 plus concentration. From that, calculate KSP. Then the second time, now in the KSP, now they are asking new pH. So to get new pH, we need new OH minus concentration. So KSP we calculated above. This M2 plus data given. So just subject OH minus, which equals 10 to the power minus 7. And H plus OH minus equals 10 to the power 14. So you can go with pH, but I'm going with this, like this. You can do whatever the way. So that we can find this H3 plus concentration equals 10 to the power minus 7 M. So that pH equals to 7. Question number 7, answer. Question number 7, answer 4. Question number 8, again asking the correct statement. The electron pair geometry and shape of SF5 plus are different from each other. So if you go with the answer, so there are no lone pairs, so it is still the same. That's trigonal bipyramid, that's wrong. Then number 2, increasing order of radii. Okay, so these two are isoelectronic, so have the second period, so the lowest. Then third period, negative charge, greater, but potassium fourth period, so it's supposed to go like this. So second one is wrong. Then the third one, the number of resonance structures that can be drawn for nitric acid is 4. Even it's unstable, the maximum you can draw is 3, not 4. Okay, that's again wrong. It's supposed to be only 3. Longest goes to permanent single bond. That's to CH3OH. The last one. With the electronegativity, you can get the electronegativity with this hybridization. So so that is the answer. So question number 8, answer 5. Question number 9. That I'm going to this Sinhala medium one. A and B are 2 organic compounds containing carbon, hydrogen, and oxygen. Separately treated with Br2H2O. Only A given these white precipitate. So A is supposed to be aniline or phenol. A is supposed to be aniline or phenol. Then the product formed when B was heated with conc-H2SO4 colored decolorized Br2CCl4. Then Y is supposed to be with conc-H2SO4 heating. So it is alkene or alkyne. Okay. Phenol or aniline, these answers only you have is number 1 and number 3. They're asking A and B respectively. If you go with A, you cannot get this. This first one, you cannot get this answer. With conc-H2SO4, this is producing just CH4. Or is it possible just to remove one water molecule? This is, I think you're going to get carbon mass or something in this. Anyway, so this is with the double bond Br2H2 giving this. Actually, there is no reaction. This we didn't do any reaction here for methanol and conc-H2SO4 because there are no like H and OH to remove from 2 different carbons. Question number 9, answer 3. Question number 10. Elementary reaction occur in closed rigid container. Temperature is constant. Initial pressure on the A is in the medium. They're given as 2P0. The pressure of the container after 2 half-lives they're asking. When A's concentration is less, coming like 2 half-lives. And this is an elementary. It's an elementary reaction. So order is supposed to equal to stoichiometric coefficient. So we can write R equals K a to the power 1. So T half equals 0. It's 8:43. Who's coming now? See, I don't know why you guys are doing this. I thought nobody's coming, so I started the class doing on office room. Now somebody's just coming here. See the time. What time is it now? See, it's almost 9 now. Anyway, so T half equals 0.693 divided by K because this is the first order. So it's independent from initial concentration. So first order with respect to A. So T half is independent of the initial concentration. So, okay, let's go. Gun. Oh my God. So, initial pressure is 2 P naught. If you divide by 2, that is 1 T half, that is 2 P naught divided by 2. Then if you divide by 2, that is again 2 P naught divided by 2 mean, if you get the answer, that is P naught divided by 2. Oh, Putta, come on. I was doing the class upstairs. Least you should say that you're coming. Because it's 30 minutes late. 30 minutes late. Okay. I thought you may come because you were asking, then I thought that you wouldn't come because you are so late. I'm doing online, okay? Okay, so that it's now the P naught divided by 2 after 2 half-lives. So you're going from making from A, B, and C. So the pressure is proportional to number of moles. So the initial pressure is 2 P naught. Just for easy calculation, I am multiplying top and bottom both by 2. 2 P naught equals 4 P naught divided by 2. That's for my easiness to getting the answer. After 2 half-life, it's P naught minus 2. So that reacted amount becomes the difference of these two, that is 3 P naught divided by 2. So that since the stoichiometric ratio equals 1:1:1, I'm doing question number 10. So that formed amount also is same 3 P naught divided by 2. So that the final remaining become addition of these three plus the total pressure. So that the PT equals 7 P naught divided by 2. So that question number 10, answer 5. Okay. Moving on to question number 11. Question number 11. Suitable method to prepare that. There are all the other issues with other temperature is different. Maybe the use this catalyst is different. So there are different issues. That bromine is orthopara, NO2 is meta. But the connection between these two is meta. First, you have to join this meta one. But they were already given that. You are here. So they are asking a very little part from that, converting this to diazonium and then to Br through the San-May reaction. Question number 11, answer 3. Question number 12. That's again very simple one. So the density is given as 1.42 grams per cubic centimeter, and then the molar mass needed, so I have calculated that. Remember, for the structured essay and essay, for these molar masses, they are giving marks. So then you have to just show this, not necessary to show the path you have calculated, but always this final thing you have to show. Okay. Then 1 cubic centimeter mass is 1.42. 1000 cubic centimeter 1000 times. And then 70% is nitric, then multiply by the 70%. Divide by 63 because to convert this into number of moles. So that this is the per cubic decimeter, this is the concentration. But the question they are asking is, which expression gives the correct volume? And in these expressions, they were given these numerical values separately. So that's why I didn't do this calculation here. Then CV to this C, nu V. So they were given this concentration and this number of mole, this volume. So that if you subject V, you can end up here by rearranging. So that question number 12, answer 2. Correct. Then question number 13, just rearranging this equation that they are given. And they say the given reaction is an elementary reaction. So with respect to A, order is 1. And also with respect to H3O plus, order is 1. And as a data, they say a constant concentration of A aqueous. Unless otherwise it's constant, you can't use that. Remember in 2020 paper, we had these all answers. Answer became all because they were not saying that concentration constant. But this time they are saying that. So we can end up with this little equation. And they were gone with pH. Then get the minus log 10 of that. Then I multiply everything by the minus value. Then just rearrange log 10 as y-axis and pH as x-axis. So that you can end up here. So that's the negative gradient plus C is supposed to be here. Only possibility is, because number 1 is positive gradient, only possibility is question number 13, answer 5. Question number 14. Okay, so first reaction is faster, second reaction is slow. Pressure of the system variation is asking. So in this reaction, this is really faster. So initially, 2 molecules become 1. Initially, 2 molecules become 1. So initially, pressure decreases rapidly because this is a fast part. Then return to initial value again because finally again they are making 2 molecules. Finally becoming 2 molecules because if you cancel off this C and C, 3 molecules. Initial 3 molecules, final 3 molecules. So that final pressure cannot be changed. Initially it's decreasing because initially they are making the intermediate, which is fast reaction. So question number 14, pressure decreases and return to the initial value again. Answer 4. Wrong. What was your answer? Correct. Wow. And you're looking at the screen like with the sour face, then I thought it's wrong. Question number 15. The solute A presents volume V, extracted twice using 2V volumes of organic solvent. Distribution coefficient is given. Aqueous phase has A initially. Amount of A remain in the aqueous phase after second extraction is asking. Just playing with these symbols they are giving. Okay, so they are saying they are giving this dissociation coefficient equals to distribution coefficient is 4. So if the X is going to organic phase, then remaining is A minus X, given that volume is V and 2V, then divide 1 by 1. So X become 8A divided by 9. So number of moles of A extracted to organic layer, that is during the first extraction, then the remaining become A minus 9. Then from A minus 9, let's say Y is going to organic layer. So that again I can write 4 equals this way. V to V cancelling off. Then you can get Y again, that is 8A divided by 81. So first extraction, second extraction. Add these two together. So that's become 80A divided by 81. So the remaining is just A divided by 81. Question number 15, answer 5. Question number 16. Compound A reacts with sodium nitride HCl. So it simply means they are not talking about the temperature. Whatever the compound, it has supposed to have NH2, which is converted into OH and releasing N2. When B is treated with potassium dichromate, it is oxidizing. So it cannot be tertiary, some sort of primary or secondary. So the NH2 group is supposed to be joined to this only 2 more carbons, not 3 carbons around. And reacting, no reaction with failing. So it is not an aldehyde. Failings, we can go with those two. So this cannot oxidize further because tertiary alcohol. And this is also giving the tertiary alcohol. That's not possible. So if you omit all those 4. Question number 16, answer 2. Question number 17. MCl2 is a solid. Suji? MCl2 is a solid which is sparingly soluble and KSP given. Which of the following correct regarding saturated aqueous solution of MCl2? Evaporation of water. Okay, as long as temperature is constant, KSP constant. As long as KSP constant, if you do not disturb by addition of any external ion, so these concentrations are not changing because it's, are they talking about saturated solution? So, and also during the vaporization, it's possible to increase concentration. So that reaction is going to decrease, so that to left to decrease M2 plus, so that is not increasing. The solution cannot be acidified by adding HCl. H plus can make the medium acidic. Chloride ion concentration of the solution cannot be increased above. There is no such, you can say exactly that level, that is possible. Chloride ion concentration of the solution can be lowered by adding distilled water and maintain the saturated. If it is saturated, as long as temperature is constant, KSP constant, so that chloride concentration is constant, it's not changing. Chloride ion concentration of the solution can be increased by adding sodium chloride to keep KSP constant. When you are adding more and more chlorine, chlorine is increasing, M is decreasing to maintain KSP. So that's possible. Question number 17, answer 2. Question number 18. Mass of Kb are given, so just calculate the molar mass. Then you can get mass divided by molar mass, that is number of moles. Volume given as 500, that's in 500, then get the concentration. Multiply with molar mass to convert this into grams. Multiply by 10 to the power 3 to convert this into milligram. So that you can get the ppm value. Question number 18, answer 5. Question number 19, answer 3. Correct. 19, answer 3. 20, answer 5. Hydrogen free radical is there. Okay, 21. Which of the following statement regarding the critical temperature of real gas is correct? Critical temperature is the temperature, highest temperature that you can leave this liquid vapor equilibrium, but beyond that level, that you have this supercritical fluid that is in between liquid vapor together. If you draw this pressure temperature curve triple phase diagram, so solid, liquid, vapor, and this critical pressure, critical temperature, at that the volume become the critical volume. It is a temperature at which the intermolecular forces can be neglected. Intermolecular forces can be neglected only for ideal, corresponding to the lowest pressure at which the gas can be liquefied, the highest pressure. That is the highest pressure. If we increase the pressure than that, we cannot do this. We cannot liquefy even if we increase the pressure than that. So this is supposed to be the highest. In lower pressure, it's possible. See, when the pressure is going down and down, see, these points are possible. So the highest is supposed to be this. Then it is that is gas liquid, not solid. See, this line has gas liquid. It is a temperature given by the van der Waals equation at any time. No such connection like van der Waals talking about this deviation of ideality and how to reach this ideality. Number 4, it is the highest temperature at which the gas phase and liquid phase are in equilibrium. Yeah, that is the highest. If you least increase a little more than that, it is become the supercritical fluid. So no more equilibrium. Question number 21, correct answer is answer 4. Question number 22. Why you were told to come into the class today? One more week with me. Next week I'm gonna do like a little, like, you know, the division or all those like fasting talk. So you can have classes only, today is 4th, then 11th, then last week is 18th then. In an experiment, magnesium metal. So magnesium reacting with nitrogen. That nitrogen is reacting with water. So if you add these two equations, you can end up here. So the stoichiometry become 2:3. Then get the volume of ammonia. Volume divided by molar volume is number of moles. So that you can get number of moles is 0.03. So multiply 3 divide 2 is the magnesium moles. If you multiply that with the molar mass, you can get the mass of magnesium. 22 answer 4. Mahan, how do you think the way I'm explaining this? Enough. Because you guys have the knowledge. Yeah, otherwise I have to go like explaining everything. Because you guys know how to write these equations and you guys know these stoichiometric ratios and everything. Yeah, that's what, like, you know, some new people are coming, then I'm sending these recordings, they are not happy. Yeah. Knowledge. Yeah, if you don't have the proper knowledge, you can do that. Stool again. It's a stool. Moving on to question number 23. The mean square speed of hydrogen at temperature T equal to that of nitrogen at T prime. A correct relationship is asking. So one single data they were given. See the knowledge. Now you have the full knowledge. That's why I'm so proud of you all. I don't expect even B class from these students that who were with me from the beginning, and not from the beginning. Even, you know, these Ramudi, Sinhala, they came being very late, but they are having this perfection now too. Okay, so two different temperatures, T and T prime. So if you get these two, they say these two are equal. But this is the equation for the temperature, 3Rg over m. And then the molar mass of hydrogen is 2, molar mass of nitrogen is 28. Equalize them. So 2 and 28. Even without calculation, you can get this answer, I guess. Is that easier? Question number 23, answer 5. Moving on to 24. Okay. Buffer solution at constant temperature contains monobasic weak acid, Ka is given, and the sodium salt. In the first condition, so that you have both this weak acid and its sort of strong base, concentrations are also given, and the total volume is 10. Then they say they were adding Ka and pKa also given. So you can calculate pKa given that Ka. And to that, they were adding volume of 1m acid. To this, whatever the volume, they were adding that. Then they are asking the pH of the system. For the second condition, the only difference is 0.1, 0.1 same. Volume become 10 plus V, and they were adding acid. So they were adding acid. Now pH supposed to be decreasing. So pH supposed to be decreasing. And they say pH change by 1 unit. So if the initial pH is X here, since they were adding acid, pH supposed to be decreasing, that change supposed to be decreasing. So new pH I'm writing as X minus 1. So you can use Henderson because this is a buffer solution. So that initial condition pH equals 5 plus 0.1 divided by 0.5. So that pH equals to 5 for the first condition. Then the second condition pH supposed to be X minus 1, 5 minus 1. That's supposed to be 4. Then new NaA and new HA, that NaA not changing, 0.1 into 10 into 10 power minus 3, but the volume is 10 plus V. But here you have 0.1 into 10 power minus 3 HA plus the newly added 1 into V. So the total volume become 10 plus V into 10 power minus 3. Then if you go with this Henderson equation again, that you can say new pH equals to 5, 4, pKa equals 5, then log, and you can simplify all these volumes and the powers and everything. Just simplify, get the answer, volume become 9. New pH equals to 4. Question number 24, answer 1. 25. 25. Gaseous discharge contributes to all 3 environmental global warming, acid rain, photochemical smog. Global warming. So any this more than 2 atomic, diatomic, triatomic, these heteroatomic, all these molecules are possible. Then acid rains from these compounds. And photochemical smog, these hydrocarbons, NO and NO2, so on. Fossil fuels, by diesel, it is producing SO2. And coal power plant, but coal power plant are not producing this NO and NO2. So it is not participating for photochemical smog. Air conditioning only giving these stuff. So municipal waste, these products, so it is not acid rains. Biofuel like carbon dioxide, we are absorbing, not releasing. And this is like very in minor amounts. So no contribution to this global warming here. So the best possible answer we can go with number 1. Fossil fuel has all this. Question number 21 and 25, answer 1. What is your answer? Just guessed or just written? Are you aware of the 14 now, like the memory? Still improving. Putta. Question number 26. Incorrect regarding lithium and its compounds. Lithium has the most negative value of electron gain. This is the electron gain that comes with the radius, lowest radius, more attraction. So easily getting electrons in. Yeah, lithium forms lithium nitride and lithium oxide. Lithium sulfide, 2 gases. Lithium carbonate, 1 gas. Lithium gives a red color, crimson red. Among group 4 elements, metallic bond strength is supposed to be strongest because it is the smallest one, so stronger electrostatic interactions. Okay, either method you can use. See, they were given this, whatever they are finding these new equations. Oxidation number methods or half reaction method, if you get used with half reaction method, that's even all right. Where can I give this? So the stoichiometric ratio is 1:1. 27, answer 3. Okay. (28). Correct regarding water and aqueous solutions at a given temperature. Solubility of the polar gas in water is lower. No, it's the other way around. Water is polar, so solubility of polar is greater. Any gas undergoes ionization in aqueous solution. So, like, you know that O2 is the best example. There are no ions, and inert gases, no ions as well. Boiling point of water decreases with increasing pressure. Pressure increasing, volume decreasing. Intermolecular interactions are increasing so that the volume point is increasing. Temperature of the triple point of water increases with increasing pressure. Triple point temperature, triple point pressure, that's a constant something, it is not changing among all these 3. The solubility of gas in water is proportional to its pressure. Yeah, pressure is proportional to concentration. Pressure increasing means concentration high, then the solubility is supposed to be high, so on. Question number 28. So the answer is 3. (29). Select the correct statement. When an aqueous solution of potassium chromate treated with Cr3+. Hang on, this is 29th one. Page 18. Sorry. Okay, this is the conversion. So first one is wrong. Electronegativities, I'm showing, see, they are expecting for you guys to memorize things from resource book, okay? They were asking just the, from left to right, it's increasing, but this manganese and zinc is different, so memorize that. aqueous solution of this hexa. This is the identification test. So that's again true. Basic property Cr2O3, that's again true. I'm showing all these properties here. And since you are making this H2S, always oxidizing agents with any oxidizing agents with H2S, it is turbid because you have sulfur here. 2 answers in question number 29, 3 and 4, question number 29. This is 30, carboxylic acids. The product formed by reaction of carboxylic acid with lithium aluminum hydride gives an alcohol upon hydrolysis. That is true, the first one. Alcohols. Number 3, carboxylic acid react with PCl5 to give this COCl. That's again true. Number 4, methane liberates. Yeah. So this acting as this proton donor, CH3 become CH4. Carboxylic acids are formed when aldehydes. Yeah. Aldehydes going through this total oxidation. Number 2, carbon dioxide is liberated when carboxylic acids are reacted with sodium hydroxide. Sodium hydroxide is an acid-base reaction. That's true if you use sodium carbonate and sodium bicarbonate. But they were given sodium hydroxide, so that is wrong. Question number 30, answer 2. 31. As the major product. So this is the product they are expecting. You can get answer A and answer D. Answer C goes this way. No point of coming BR here. 31, AD correct. Answer 4. 32, which of the following statements are correct regarding plant sources? That I'm going to go with the English medium one. Essential oil contain complex mixtures of volatile constituents of plants. Yeah, cinnamon, I have given an example. Biodiesel is produced from non-volatile. It's in the resource book. Actually, you guys know essential oils are volatile, okay? That's 2 different things to remember. Methanol is not used to produce, not is wrong. Basically, we use methanol. Maybe methanol from plants or methanol from oil refineries. Ethanol produced by fermentation of plant material is regarded as a renewable energy source. Yeah, that is example. One of the example is the sugar cane. Anyway, so ethanol coming from plants, so we consider this as a renewable. Question number 32, A, D correct. Answer 4. 33. Which factors does electron potential of the M2 plus M solid depends? It's not the surface area. Concentration, yes. Temperature, cell is exothermic, yes. Volume of the solution, it's maybe because let's say the more volume has more aqueous, but it is not like they are not explaining this nicely. If we are going with standard, that it is always going with the constant concentration. So it's not depending exactly on the volume. 33, BC correct. Answer 2. 34, CO2 when reacting with CO2 and sodium carbonate. only carboxylic acids. Both they were given carboxylic acid. This is even they have given this is OH. You have to get the answer. CD correct. 30 for answer 3. How did you get this paper? Website. Huh? Ah, from that. I don't have a good one here. Is it good one? I want to get a copy again. See, this is so bad. Okay. So moving on to question number 35. It has a 21 as well. Okay. So what is the link I said? It is Matsapi. Is it the one I sent? Oh no, the one you sent me. Ah, okay, that one. I didn't check that. Okay. 35. Which of the following statements are always correct regarding weak electrolytes? So I have given a couple of these examples. Conducting an electric current, the fraction of the current carried by this anion is greater. Usually, it's supposed to be greater for cations because you know the best. There are different factors, not only this, and also supposed to go with the H plus because H plus has the highest speed. Conductivity of anion is greater. That we can say. Only a small portion. No, for equilibrium conditions, we are talking about the dissociation less than 5%. Total dissociation means 100%. Even 50%, even 60%, even 10%. These are not 100%. So these are partial dissociations. It's not always be like very small. So C is incorrect. Fraction of molecules of weak electrolytes dissociate increases with dilution. That is by the Oswald dilution law. That's true. Only D correct. 35 answer 5. (36) Correct regarding global environmental issues with volatile halogenated hydrocarbons. What was your last marks? 21? For 20 paper? 41. So you're continuously now maintaining above 40 now. And are you maintaining also the structured SNSE also? So maintaining. So are you managing like in 40 average? Yeah, that's more than enough, Baba. Okay, these three contribute to global warming definitely. Chlorofluorocarbon. Troposphere, let's see. Chlorine radicals in stratosphere. Troposphere is the lower, stratosphere is the higher level. So B is incorrect, D is correct. HFC has no contribution. Hydrofluorocarbon, no chlorine. AD correct. 36 answer for who's that? Parents? Just answer that. If your parents don't wait, I know how frustrated they are these days. Question number 37. Which of the following statement is correct with regard to allotropes of carbon? Carbon atoms in diamond, tetrahedral. For other carbon, three-dimensional lattice, all are correct. Graphite is composed of two-dimensional layers held together by weak van der Waals. It acts as a good lubricant. That is the reason. Yeah. Diamond is a good conductor of heat is all right, but the electricity, no. Graphite has considerable higher melting point than diamond. No, it's higher for diamond. CD incorrect. AB correct. 37 answer 1. 38. Which of the following regarding gases correct? Molecules move at different speeds, yes. In a sample of real gas, yeah. Whereas all the molecules move at same speed, no, wrong. Either ideal, either real, no same speed. Ideal gas can be liquefied at extremely high pressure. Ideal, yeah, not talking such things. Ideal means there are no interactions. Just checking where it's coming from. Yeah, that's Ramudi. Maxwell-Boltzmann speed distribution curve of an ideal gas is symmetric above the maximum point. Maxwell-Boltzmann speed distribution curve is symmetric. It's always asymmetric. The compressibility factor of a real gas depends on pressure. Yeah. Only D is correct. 38, answer 5. That's simple stuff they are asking. 39. See, earlier they were just asking question with this. This time they were given solid, liquid, and gas here. So you can use that knowledge for that last question. See how funny. Maybe these two questions made by two different people, I guess. Which of the statements are correct regarding the phase diagram of the pure substance? So this is not water. Water is supposed to go the negative deviation, negative gradient here. A number of molecules in the volume always higher than the gas that in the liquid phase. No, that's for water, but interaction of liquid is also greater. So the vapor has in gases less molecules. This is for other stuff, not water, so it is wrong. The liquid phase and the gas phase never C or C line. Liquid gas equilibrium. OA line, solid gas. So BC incorrect. When the system is at the triple point, the rate at which the gas is converted to liquid is equal to the rate at which liquid is converted. Yeah, triple point. All these three are equal. Liquid, gas, solid, all are same. D is correct. Question number 39, only D correct answer 5. 40. Which of the following statements correct regarding the given industrial processes? Directly, magnesium, we cannot use. You have to remove these hydroxides, sulfates, all those. You have to remove them using different these compounds. So cannot. In the process of sodium hydroxide, the use of membrane cell is more environmental friendly than mercury. Mercury, yeah, pollution. Efficiency of solar process used to produce sodium carbonate can be measured by cooling the air. Ammonia tower we maintain to 50 degrees Celsius because the reaction is exothermic. V2O5, catalyst for sulfuric, not rhodium. Rhodium goes for nitric. See, they are playing with your memory. 40, BC correct, answer 2. 41. When an acidic potassium permanganate with H2O2, colorless, ferric converting to Fe2 plus converting to Fe3 plus, so it is yellow brown, that's true. H2O2 can act both as oxidizing and reducing. So that's why both these two are happening. See, I'm showing two different reactions. The first one is acting as a reducing agent. In the second one, it is acting as oxidizing agent. Because of that, they are giving both these colors in the first statement. In the first statement, these two colors are coming with this oxidation and reduction. So that we have to accept some sort of explanation is there. So that question number 41, answer 1. 42. Energy of a gas in a closed rigid container with thermally insulated. Thermally insulated means the isolated system. Both energy and matter of an isolated system do not exchange. That is the reason. So answer 1, because this thermally insulated system is acting as isolated system. Cl2 gas is undergoing disproportionation on reaction with water, giving HCl and HOCl, that we know that. HOCl has the highest oxidizing ability. That's again, remember, that's because that, yeah, okay, here this chlorine oxidation number is +1. So if you compare that, you would think that HClO4 +7 supposed to go through reduce very easily, having the highest oxidizing ability. But in your resource book, they were explaining that with all these 4 oxygens, it is not easy. The other species getting closer to this. So just remember that the second statement is correct. I have given this to theory as well. Memorize this. Okay, so this acidity is different. Acidity is other way around. Acidity of perchloric is greater, but oxidizing ability of HOCl is greater. But the explanation doesn't come through that. 43, answer 2. When a catalyst is added, the portion of equilibrium catalyst, whatever do, increasing both forward, backward, so the equilibrium portion not changing. A catalyst always increase the rate of not more than, same. Both are incorrect. 44, answer 5. This acetylenic grenade can be prepared by the reaction between this and methyl magnesium bromide, CH3, MgBr. The alkyl group of grenade reagent act, because it is accepting this H+. So this actually is a Laude-Bronsted acid. So you can accept that. Question number 45. Since it is acting as an acid, it is, as a base, it is accepting. Just write there Laude-Bronsted, okay? So it is acting as a base. With that, this H is releasing to make this grenade. So explanation is there. 45, answer 1. 46. Reaction of HCN with any aldehyde gives a product containing a chiral carbon atom. A carbon atom joined with 4 different groups is chiral. Okay. First one wrong. I have explanation. Let's see. If you go with this first member, you have 2 hydrogen. OHCN is joining, but with 2 hydrogen, that's not chiral. So 46, first statement incorrect, second statement correct. Answer 4. 47, main byproduct is calcium chloride. Yeah. Calcium oxide is also used to regenerate ammonia. That's again true. During that reaction, it is producing this calcium oxide. When calcium oxide reacting with ammonium chloride to reproduce ammonia, this is producing. That's why calcium chloride become the main byproduct. So that happens by this equation. It is happening by this given equation. So it is explaining this. So that answer is 1. Either OHO or Na, this is true. Disonium ion can act as electrophile. That's again true. Since this is acting as an electrophile, it is making this compound. So answer is 1. Benzene disonium chloride reacts with phenol to give not only this or maybe this. This actually is the most correct answer, so that this become wrong. this OH supposed to be ONA. Because sometimes they are taking this is wrong when we were not writing this sodium, remember? So that then student can think, no Na here, so this is wrong. First statement wrong, second statement right, 48 answer, then 4. So there are 2 answers for 48, 1 and 4. But this paper is way success comparing to 21 paper. That is the effect of COVID. This is the most unsuccessful paper because we came from the 2000 onwards to this. We never had any paper with 5 all answers. COVID effects. 49. When the strong acid is titrated with aqueous ammonia, neutral solution is not obtained. Yeah. NH4 plus react with water to forming H2 plus. That is the reason. The weak part, conjugate acid, releasing H plus to the medium to give this not neutral condition. Answer 1. Understood? Because of this reaction is acidic, that's why it is not neutral. For 50, atomic oxygen is an essential factor for the formation of ozone in the atmosphere. Yeah, atomic oxygen in the atmosphere is produced by decomposing of molecular oxygen, that's true. But is it the only way? Even by decomposing O3, it is making this atomic oxygen too, not only by, yeah, this is true. This is, by dissociating O2, you can produce atomic oxygen, but also that is coming from O3 as well. For the second statement, it is not true. Question number 50, answer 3. Check first top 10. Then you guys have to excuse me again with this. I couldn't find any good. Now Pahan is saying, I just want to check your paper, Papa. Is it a good one? But that's all I can answer. Is it good? I think. How many? Okay, only Sahan here with me today, and he's having 44. My pencil. Yeah, for this paper, highest is from Tharumini, that is 47. Deepna 46. It's good, really good. Okay, well, let's go on with the I'm moving on with structured essay, but almost all these parts, I'm going to go with the Sinhala medium one. Anyway, I'm giving all these explanations. I have the English medium one, you guys can see, but the explanation is not that better. Still, I didn't have time. You know, I seriously didn't have time to go with this. To complete this. Luckily, I think it's good because now this is not good and Pahan found this Tamil Guru, I guess. Just this good papers, better than my one. Even the single one is not good. Okay, state whether the following statements true or not true. Melting point of KBr is higher than lithium iodide. Go with both the polarization power and polarizability. So that's correct. Both polarization power and polarizability of lithium iodide greater. So it has more covalent nature. Beryllium group 2, it is positive. That's again true. Third one, spacing between these adjacent direction to decreasing wavelength. Decreasing wavelength mean increasing energy. So decreasing wavelength mean increasing energy. That's again, so that's true. Answer 4. This is the T-Broglie equation, lambda equals HOMC. So same velocity, H over MC, mass, lambda, mass and lambda, knowing mass. So we can get that lambda n2 equals 8 divided by 7 lambda O2. So lambda n2 is greater. So the fourth one is incorrect. And fifth one, effective nuclear charge felt by valence electron of carbon is greater. No, nitrogen is greater because nitrogen has more electrons, more charge. So it is greater for nitrogen. Then the next one, for this, all bonds are not same because this is not carbonate. You have two hydrogens here. See these resonance structures are different. These are, and actually these resonance structures are unstable, very less contribution to this structure. So they were messing around with this CO3 2 minus. So that's again wrong. Okay, then Lewis. Then they want us to get these oxidation numbers for these. Okay, 1, 2, 3, 4, 5, 6, 7 plus 7. This is only one bond, so plus 1. Okay. So this blue one I'm showing here with blue arrows. Orange one I'm showing here with orange arrows. Two structures. And this N1, C2, C3, N4, 3 trigonal planar bent sp2, C2, 3 trigonal planar sp2, C3, 2 linear sp, N4, 2 linear sp. Then check this. Sigma, either atomic orbitals or hybrid orbitals. Actually, they were not given marks to mention in that hybrid orbital or atomic orbital. So I didn't do it here, but still instruct you to draw that. Earlier they were given marks. And these pi bonds always supposed to coming from 2p because there are no like third periodic elements, only second period. Whatever it is, always 2p. Then they want us to go with this N1, C2, C3, and 4 bond angles. SP2 trigonal planar and then bent with shape. So whatever this, like if you have written like 119, 118, 117, that's correct. Exactly, SP2 trigonal planar 120, but even if you write 121, 190, that's correct. SP 180, SP 180. Go with the first part is going with this electronegativity. Then the second part is going with this hybridization. See this. If you are going with same atoms, you cannot compare only with this hybridization. First, you have to go with comparing of these different atoms with their electronegativity. Same atom, okay. Different atoms go with their electronegativity first. All right. Next question. A laser emits photon of wavelength 695. To which region they are asking? 695 is in between 400 or 422, 800. Memorize this. So it is a visible region. Calculate the energy. E equals h nu equals h over lambda. But that's per mole. Photon per mole is asking. So you have to multiply that with the Avogadro number. So it's 172 kilojoules per mole. What happened, darling? Couldn't you get the answer? Okay, you were writing? Just. Okay. A molecular formula is AX3 and it has 3AX sigma. A can be. See these connections they are making always to this previous and to next. Polar, pyramidal or T, non-polar, it's just the trigonal planar. It's just the trigonal planar. Then examples, AX3 polar, so you can go with any ammonia, PH3, NCl3, PCl3, H3O plus, T-shape, ClF3, BrF3, IF3, any. So AX3, BF3, BCl3, BBr3, ASCl3, or any of these. Question number 2. If you want this, how many bond pairs, how many lone pairs, how many, what is the shape and everything is there. A is the question A to T given below related to the element or species designated as A, B, C, D. A is S block element. Atomic number less than 20. Reacts with water vigorously. So S block supposed to be group 1. With ignition reacting, strongly basic, all are adding to group 1. Evolution of a gas. React with excess O2 to give superoxide. Reacting with excess O2 superoxide, potassium and below element gives superoxide. In sylvite, that is potassium chloride. Potassium chloride. So that the element supposed to be potassium. Then the electron configuration 1s2 2s2 2p6, 3s2 3p6 4s1. The gas is H2 gas. flame color, lilac, violet, purple, whatsoever. Superoxide reaction, K plus O2, KO2. First ionization energy, less or greater. Lower. Going down the group, radius increases. Distance between nucleus and outermost electrons increases. Effective nuclear charge acts less. Shielding effect increases. Therefore, electron nuclear attraction decreases. So you have to go with both radius and shielding effect together. Silvite KCl. Silvite KCl. See, they're asking. You have all these general names. Part B. B is an anion containing only two elements, X and Y. And the ratio is 2:3. X and Y 2:3. Both X and Y are P block elements. Same group. Same group, if these comes together, that's almost all the way, all the time it's supposed coming from this oxygen group. You know, oxygen is reacting with all the other elements. Atomic number of each element is less than 20. Electronegativity of X is less than electronegativity of Y. When X reacted with hot concentrated sulfuric acid, colorless gas with pungent smell. Okay. So something reacting with sulfuric giving this pungent smell, colorless gas, SO2. So that's supposed to be this sulfur. So the same group is oxygen. Oxygen's electronegativity is also greater. H2S, SO2O, NH3 are the pungent smell gases. So sulfur with oxygen, so S2O3 2 minus 2:3 ratio. Then this anionic structure. Then the oxidation number of this compound is +4. Identification, any identification test you can write. I've written just one here. Addition of dilyl HCl of dilyl H2SO. You can just write addition of dilyl HCl. Release a gas with pungent smell plus colloidal suspension or turbidity. Results the turbidity. And then A is the cation, potassium cation thiosulfate. So the compound becomes potassium thiosulfate, K2S2O3. Now moving on to the next part. C is an oxidizing agent. Oxidizing agent may be oxygen. That's an element again. In the ratio 1:1:3, 3 elements it is composed of. C is what? C is ABCD. It's element of species. This is not an element because it has 3 elements together. So it is oxidizing agent, mean it can consist oxygen then. One of the element of C is A. So it has then oxygen and then potassium. Other one coming from B, a P block. One of these 2 elements is also present in B. B is thiosulfate. So then either sulfur or oxygen, that we already know oxygen is there. You can confirm that. The salt formed silver, that is yellow, insoluble in ammonia, that is silver iodide. So the other element is supposed to be iodine. Okay, good oxidizing agent. 1:1:3. You can just go with combination. So usually oxygen is greater in this compound, so the oxidizing ability is there. So it's supposed to be 1:1:3. 3 means 3 oxygen, so it is KiO3. KiO3. D C has these two elements in D, potassium, oxygen, or iodine, reacting with C, thiosulfate. This is giving red-brown. That's supposed to be I2. So this is supposed to be then Ki. Ki plus, Ki plus C. Ki plus iodide giving I2. So they're asking these reactions, check them. And these colors are asking, indicator is charge, color difference is blue to colorless. All right. Which part have forgotten? Which part you forgotten? Really? Okay. Lost the annotation. So these days they're sharing their happiness because they got these placements. For 2022 students, they were gotten already placements. And even these students who were thinking like they wouldn't go for some sort of a higher stuff like doing this second child, but they are getting some sort of this successness, like some are going to this agriculture faculty and so on. Some students who were not coming to me like very regularly, but they were saying, from my support, they could do that. I'm really glad that. Anyway, so now they are in whatever this safer place, somewhere in Sri Lankan Government University. That is the most important thing. X and Y are two volatile liquids that form an ideal solution. Pressure is given as this external pressure 1 into the power 5. They want to show these regions. Vapor phase, liquid phase, and this equilibrium. This is 60. So X 60. And see, this is 120. So T naught Y is supposed to be 120. And 100, 50, 50. If it is clear to you, this is the midpoint. So then from this is 50, then this is supposed to be 60. So you are starting from 60. And 100 is the boiling point. Then go the other way around until you cut this liquid curve coming back. It's in between these two lines. So this is 0, 10, 20. So it's in between those two, it's 15. Okay. They want us to calculate the saturated vapor pressure of X at 100 degrees Celsius. Calculate the saturated vapor pressure of X at 100. So this is actually the mole fraction that we found. Then Px equals P naught X XX liquid. Dalton's law Px equals Pt into XX vapor. But both these are equal to each other. So that just subject P naught X. So the total pressure given, then two different molar fractions given, then P naught X equals 4 into 10 to the power 5 Pascal. That part is done. Then, in a separate experiment, mixture of X and Y was allowed to reach equilibrium. Temperature is constant at T. It was found that the liquid phase in equilibrium with the vapor phase contain 0.1 X and 0.1 Y. Saturated vapor pressures have given. Calculate partial pressures of X and Y. Okay. Rouse Px equals P naught XXX. Py equals P naught Y XY. And molar fraction is half. Multiply saturated vapor pressure. So 2 into 10 power 5. And here, saturated vapor pressure, actually this is not, they were given here, okay? Use them, they were given here. For Y it is 2 into 10 power 5. So Py become 1 into 10 power 5. B, okay, this is the condition. Acetic acid, they made the solution as solution Z. Determine titrate sodium hydroxide. Z volume is 12.5. Sodium hydroxide, they were using 0.05, 25 cubic centimeter. And the first part, concentration of Z, 1:1. Na, sodium hydroxide amount is supposed to be equal to the acetic concentration, 0.0105 into 25. So that's supposed to be the acidic concentration, 0.1 moles per cubic decimeter. Calculate the pH of the solution Z. Acid, dissociation constant is given. Let's say the temperature is constant. So acetic acid releasing H plus to the medium or H3O plus to the medium. It's H2O, this is supposed to be H3O plus, okay? Okay, so initial concentration if C, this is X and X. When X is very small, concentration becomes C. They are given 2 marks for that. Let's write the Ka expression, which equals X squared divided by C. So X equals root Ka divided into C. So Ka and C we have. Then get the H3O plus 1.35 in 10 power minus 3 moles. Get the minus log 10. Writing this, they are giving 2 marks. pH equals 2.87. Okay. Part 3, to another 100 cubic centimeter of Z, 0.2 grams of sodium hydroxide added. pH of this solution, assuming that the volume temperature constant. And let's see whether they are giving this Henderson, sorry, giving this buffer or not. You can go with Henderson, but they were given marks for both. So 0.1, 100 cubic centimeter. So you can get initial acidic concentration, number of moles. Volume is 100 cubic centimeter, 1 in 10 power minus 2 with the CV. Here the mass of sodium hydroxide divided by the mole mass. Then you can get the number of moles of sodium hydroxide. Sodium hydroxide is reacting with acetic, and this is in excess, 0.01. So that remaining acidic become the difference between sodium hydroxide and acetic acid, 0.5 in 10 power minus 2. If you divide that by this total volume, because they were adding sodium hydroxide as a solid, so the total volume is the Z volume. Divided by 100, you can get the acetic acid concentration. Now the sodium hydroxide is not there because that is a limited factor. It is reacting fully with acetic, converting to sodium acetate. So now we have the sodium acetate concentration. Divide that sodium hydroxide number of moles by volume, that is 0.05. Then I'm just gonna subject H plus from this equation. Not that equation actually. They were not given marks for that equation. I was not written that then. It's here. We have written that equation here. So I'm going to use that equation and saying equation number 1 here. Saying just equation number 1 here. Just subject H plus, Ka given, acidic concentration calculated, sodium acetate calculated, get the H plus concentration minus log 10, get the pH equals to 4.74. pH equals to 4.74. Does the sodium describe behave this buffer solution? This solution is behaving the buffer, yes. Solution contains a weak acid and sodium salt of its conjugate base. So that goes with the explanation. So that's true. We can admit that. Part 5. Then in another experiment, they were using 0.8. Now what happened? Let's see. Now the limited factor is acetic. So just calculate this total acetic again 0.01. But this time sodium hydroxide becomes 0.02. So the remaining is sodium hydroxide and sodium acetate. So the strong base, sodium hydroxide, controls the pH of the medium, so that does not acting as a buffer. Four, ABC are structural isomers having the molecular formula C5H11Br. Structural, chain, position, functional group. But they were given one single, this alkyl halide, so we cannot go with this functional group, just one single. C5H12 equivalency, that is saturated, CnH2n plus 2. And of these three, B exhibits optical isomerism. B. So I'm gonna make B first. One hydrogen, one carbon, two carbon, carbon and bromine. Or you can just add bromine, hydrogen, carbon, rest of the part. Anyway, so this is a longer chain. Oops, where's the annotation? See, this annotation is not working. These Zoom people are not that successful like these phone people. Phone people, they anyway do this good job, but Zoom people still, they are trying to make this better. Okay, so this is the longer chain. I have put numbers so that I'm just making it straight, okay? Then positional isomers A and C. Then A and C supposed to show same skeletal structure. So I'm going to draw all these 4 other possible structures. Same skeletal structure. You can go with all these have same 1, 2, 3, and 4. Yeah, same structure. We can't say anything. ABC, sodium hydroxide, DEF. Okay, now all these bromine become OH. Still no chance. Move on. D, E, and F having molecular formula this. Respectively, D, E, F were treated separately PCC. F did not react with PCC. F. Who's not reacting with PCC? Tertiary. So this is supposed to be F. From F, you can go to C. DE reacted with PCC to give DH. All these are reacting. DH gave color precipitates with 2,4-DNP. Yeah. DH and silomira with ammonia. Silomira with ammonia. So that aldehydes. How do you know which one is G and which one is H? Have we given any clue for that? Is there a way to distinguish between G and H? A and C. A and C. Yeah. But then A, C, B all A, B, C all have same skeletal structure. A, B, C. F is okay. Ammonical silanitrate. How did you distinguish? I'm not sure that. Is it possible to distinguish A and B? Huh? Yes. Silly me. Yeah, we already distinguished B with optical isomerism. Yeah. So this is the path. B has this optical isomerism, so we could distinguish by that. So these are the answers. See, all of a sudden I'm getting nuttier. Moving on. Then these answers. Ester, so two identical R groups are joining for the first one. Alkyne hydration, the second one. Third one is aldol with acidic heating. So this alpha beta unsaturated. This is just Ki, the Sanmei. Actually, not the Sanmei, but the same sort of a Sanmei reaction. Sanmei is supposed to be, see, I have just refreshed. CuBr, so joining of bromine, chlorine or cyanide. Iodide is not Sanmei, but anyway, answers. Then they want us to show this just typical, always we are doing that. See how they were given marks. Just go with that. Okay, moving on to question number 5. because it took some time for me to translate all the essay part. That's why I lost this structured essay. Is it disturbing to go with Sinhala one? Little disturbing. That's okay, because you have the paper with you. But you don't have the paper with you today. Ah, you have the paper. But you didn't do that part. Ah, okay. Yeah, if you have the paper with you, my explanation is more than enough, I guess. A gas mixture containing these three, CH4, C2H6, and O2. Volume, temperature, pressure were given. First part, calculate the total number of moles. PV equals nRT. Just the total number of moles you can get, 12 moles. Then they burn them completely. When the temperature is 800 Kelvin, that no, this water is existing as water gas as well. They are giving the total pressure again. This pressure given and afterburn pressure is given. So that you can calculate because others are constant, not changing. New temperature is given as 800, so you can calculate the total number of moles again. That's 12.5. And then write the balance equations. So the third one is just asking the balance equations. Giving physical state, 800 mean, just they are expecting you are writing gas here. See the stoichiometric ratio become 1:3.5 here. Okay, so the fourth part. Only one of the two hydrocarbons above contributes to the change of in the number of moles in gases before and after combustion. Because here you have 1 and 2, 3, 1 and 2, 3. Gaseous components in both sides of equation number 1 are equal. So number of molecules of gases change change by 1. Reactant gas molecules of equation 2 is 9. 9 here. 9. This side 9. Products are 10. So the difference become 1 mole. Okay, so the question they are asking, calculate the number of moles of this hydrocarbon initially introduced into the container. Okay. Difference is 1 mole. 1 mole difference came by when they are using 2 moles of C2H6. So initial NC2H6 for the change, they were using 2 moles. But the real change came between here. See, the initially 12 moles, now 12.5. So that true difference is 12.5 minus 12 is 0.5. Then the difference is supposed to be not 1 mole. Difference is supposed to be 0.5. For 1 mole, you're supposed to have 2 moles. For 0.5, you have then 1 mole. So for 1 mole, it is the difference is 2 moles. Then for 0.5, 2 into 0.5, just the number of moles of ethanol, ethane supposed to be 1 mole. There. Did you do this question? Then the fifth part, they're asking a couple of questions. Container was then cooled to 300, water removed, and then now they are saying the pressure. They were given this new pressure. So to new pressure, if we calculate total number of moles at 300, now the number of moles is 7 moles, but earlier it's 12.5. Without water, it's 7. Then the number of moles of water is supposed to be this rest of those, that is 12.5 minus 7, that is 5.5. Number of H2O produced from the combustion of C2H4. Now we know C2H4, we have only 1 mole. Stoichiometric ratio from the second equation is 1:3. 3 times of that, so that's supposed to be then 3 moles. Part 3. Number of moles of H2O produced from CH4. Then altogether 5.5. 3 coming from C2H6. This is like a kindergarten little question. How easy. Okay, then water came from CH4 is 2.5. Then from equation number 1, CH4 to water is 1:2. Then 2.5 divided by 2, number of moles of CH4 is 1.25. We know all these moles together. So all the moles subtract C2H6 subtract CH4 is the number of O2 moles, 9.75. 9.75. Part B1, they were given all this information. Standard enthalpy of change for the reaction. I'm writing the reaction. They were given all these formation enthalpies. Actually, easily you can go with the state function method. Products are ethane and water. Reactants are CH4 and O2. Product enthalpy, reactant enthalpy. We are to show this oxygen, sorry, 0. Then the value become 199, or otherwise you can go with the thermochemical cycle, but it is time wasting. So the best method is going with this state function. Then the next part, entropy is asking. They were given the entropy data as well. Just go with the same way as state function. Product entropy minus reactant entropy, that is plus 113.5. Enthalpy known, entropy known, temperature given. So 500 degrees Celsius. Convert this into kilojoule by multiplying 10 to the power minus 3. Then Gibbs free energy is minus 243.05. Giving reasons, increasing temperature favors. And entropy is negative. Okay. Delta H above reaction is negative. Exothermic. When temperature increasing, it is discouraging forward reaction. That is one way you can explain. Delta T equals delta T minus delta H minus T delta S. Delta S negative. When temperature increasing, T delta S become more positive. Delta G become less negative. Spontaneity decreases. You could give both answers because last time, couple of years ago, they were like, oh, they want to give either this answer or this answer. But I'm not saying that. I'm just saying you're going to write everything. I told you guys this can happen. This time they were expecting both answers. They were splitting marks for both answers. So whenever they are saying oh, don't go for that. Write everything for your exam. Question number 6. This reaction is saying the elementary reaction. Elementary reactions, order equals, stoichiometry equals molecularity. And this is a given reaction. Forward reaction rate and backward rate. And these are the rate equations. At equilibrium, these two are equal. So if you can equalize these two then, so that you can end up Kc equals K1 divided by K2, or Kc equals this, Bc divided by A. They're expecting both Kc, K1 and K2. Both are expecting. Part 4, they were given A, B, C. Concentrations are given. From this expression, they were given all these concentrations. So using them, you can calculate Kc separately. you have three equations, not using the rate law, but using equilibrium law. And now you know you can get these. This is the first time they have done that, but you don't have any issue. You just follow the path they are showing you. From that, you can get these. If you write all these cases, if you divide one by one, between 1 and 2, you can find B equals to A. Between 2 and 3, you can find B equals to 2C. So that B equals to A equals to 2C. That's what they want us to show. Calculate the value of equilibrium constant Kc of the above. You can use any of these. Okay, using small integers. Let's say smallest, let's say A is 1, then C becomes 0.1. That is not a whole number. If A is 2, then C becomes 1. Then we have to consider the smallest number for C is 1. So that C is 1, A is 2, and B is 2. I'm going to use the first equation to calculate Kc. The only unknown become this ABC. This is a square value. Then answer is this. Kc equals 1 into 10 to the power minus 5 moles per cubic decimeter. 6 part B. Remember that we did this kind of a question. They were given this kind of a question for in resource book. That's why I have added all those model questions to your paper, to your theory. I was not happy to add all those to theory note because theory note became like 1 day longer, 4 hours longer after they done this new resource book. But luckily now I'm happy because I have added everything. Now they're asking questions from those parts. P, Q, and R, this reaction. They are giving some information. First part, they want to show this energy profile. Energy, kilojoule per mole, 3 plus 1. Just writing reaction coordinate, 4 marks. Writing the reactants, 4 marks. Writing the products separately, 4 plus 4. They were not given marks for these two, but it's better we need that to calculate the next part. Then this is the active complex. Just saying active complex, 4 marks. Okay, so yeah, now you guys know this is total activation energy and this is 50. So the backward supposed to be then this amount. So that's the backward reaction activation energy, which is 40. Explain the effect of increase in temperature. Explain the effect of catalyst. Forward reaction is endothermic. Above forward reaction, delta H plus endothermic. When temperature increases, equilibrium point shifts towards right according to Le Chatelier's principle. Therefore, when temperature increases, forward reaction rate increases rapidly compared to the backward reaction. Forward reaction rate increases rapidly compared to backward reaction because you guys know when temperature increasing, both forward backward increase. And Kf is great, so that Kf become greater than Kb. And since this is the Kc, then Kc is increasing. Today itself, you got this exactly correct explanation that we're supposed to give for this, how this is increasing Kc. Another way of explaining, they were expecting that. Then by catalyst, reaction rate of forward backward together. Catalyst increases both forward and backward reaction rate by same factor. Temperature is constant, equilibrium constant does not change. Since the temperature is constant, equilibrium constant does not change. Moving on to question number 7. All right. you are provided with the three metal rods LMN, and concentrations and these cations were given. And they have given these data. We can oxidize, we can reduce M by N. That's the data. But N and L together, no reaction, mean we cannot reduce L. So the oxidation, reducing power is less. Then the first part, giving reasons, arrange these three, increasing order of their reducing ability. If you go with this reaction, that M2 plus can reduce, N can reduce M2 plus to M very easily. Reaction is spontaneous. N solid reduces M2 plus. So the reducing ability of N supposed to be greater. Reducing ability of M supposed to be greater. So N and M exist like this. M and N. Then N can reduce L again. But this is not happening. This is non-spontaneous. N cannot reduce L2 plus. Then reducing ability of N supposed to be greater, like this. So N is, L supposed to be the greatest then M is lower than N. So reducing ability is supposed to go like this. So 5 marks to say this, 5 marks to say this. Part 2. Electromotive forces, they were given. Electromotive force of 2 electrochemical cells prepared using L. Each of the other 2 electrodes are +3 and 1.1. So we can arrange these three like this. So the greater distance, larger. So this is supposed to be L and M. This value is supposed to go for L and M. This is lower. So the less distance. So this is supposed to be L and N. Rest of the all are really, really easy. E naught cell non, anode non. You can calculate cathode very easily. E naught cell non, anode non. You can calculate the cathode easily. M value becomes 0.3, N value becomes minus 0.5. Did you do this question? What these answers? Goodbye. How about other two? I guess your mom and dad is happy for you now. Are they? Your mom is not mentioning anymore. Yeah? She does? Still? Really? You can stay relaxed. Always chasing you to the study area. Potentiometer is not connected between L and N. They are asking that. Both these are electrochemical cells. So this is like series connection because this is just one single M. And L is anode. Electrons supposed to flow from here to here. Then N supposed to be again anode. M is always the cathode. Clear that? See? M supposed to be always the cathode. L is anode here, and N is anode here. These are two electrochemical cells. B and C join with common M connected as series circuits. Therefore, charge amount and current is also common. Yeah, charge and current is also common. Okay, the first part, calculate the potentiometer reading. Okay. This part is, I know, a little complicated. Go through this like a couple of times until you feel comfortable. So we can write E naught cell equals E naught cathode minus E naught anode. Now we separated these two. So for the first cell, let's say AB, M is cathode, L is anode. So we can write E naught cell this way. Then the second one, again, M cathode, N anode. So we can write E naught cell for the second cell this way. So the direction here of electromotive force is the direction of electron flowing, that is from L to M, anode to cathode. Direction of electromotive force equals direction of flow electron, that is from N to M. So now you can see this is L to M, N to M. Electron flow are going through the opposite directions. That is a one thing. And then the second thing, E naught cell AB is greater than E naught cell CD. That's with this, the gap between the position of the electrochemical series, we can get that. Then this is supposed to be the larger one. This is a smaller one when we are getting the difference. So the resultant acts on AB cell to CD cell direction by external circuit. So the reading of potentiometer is E naught cell difference goes from this AB cell to CD cell. M and L and M, yeah. So this is the first cell, AB cell, this is the CD cell. And so that you can cancel off, this is exactly the same. Then L value we calculated earlier, given data L value, so that potentiometer value becomes 0.3. Clear that? Let me show you the full explanation again. Think and go through this again. I think this is easier for physics students. Read this as a little theory. Then part 2, write the electrode reactions that occur at each of these electrodes. Okay, now the current is passing. Current is passing, only 4 reaction occurs. And E naught cell AB is greater than E naught cell CD. Therefore, high E naught cell controls the direction of the flow. Therefore, it is going from A to D. So A oxidation, D reduction, B reduction, C oxidation. Clear? So that A is L oxidation, B M reduction, B is M reduction, C, that's again M oxidation, and D reduction. Okay. I'm just showing the full part. I think a gutter has broken. I keep forget to tell this with sir. I just texted otherwise. Because now I'm doing some of my this education stuff, so I'm really busy, so I forget things. Right at the time, I'm just paying attention. Question number 7, part B. They don't want you to find what is this element. They are just saying the element. So this element is manganese. Even not saying the highest oxidation number. So they are just giving the element because they know now you guys know this. Atomic number 25. So 4H2 3D5. Different oxidation numbers +2, +3, +4, +7. +4 is the most stable. +5, +6 unstable. Dissolve this MnSO4H2O in water, and color of solution P. Initially, that hydroxide that has a pale pink color, and then a chemical formula for this color. Sorry, that's not hydroxide. That actually is this complex, hexa-aqua complex, hexa-aqua manganese 2 space ion, not the hydroxide. Okay. Then part 4, sodium hydroxide. Makes the manganese hydroxide. Sunlight oxidation, blackish brown, HCl, making this complex, and they are asking those 3. And then the 5th part, these oxides, oxidation numbers, and acidity, basicity. And chemical formula, most common oxyanion, MnO4- 3 marks. Acidity and acidic and basic conditions, half reactions. Water quality parameters we are using for Winkler method. Determination of dissolved O2 in water sample. Determine dissolved O2 in water sample. Okay. See? Question number 8. Organic one. No, is that organic? Yeah. Compound P was converted to V. P has 3 carbon. Oops. P has 3 carbon, V has 4 carbon. 3 carbon, just this. You have to start from NH2. Sodium nitrite DLHCl, NH2 convert into OH, PBr3O PCl5, OH convert into Br, magnesium dry ether, Br to MgBr, to that 1 carbon HCHO, they were given those, 2 Grignard, CH2OH, oxidize, H plus K2Cr2O7COOH, PCl5, COOH converts to COCl. Okay, all the answers, symbols, everything is there to check your answer. Then they're asking if P and B react with each other. So this is the product. They are making the amide formation. Propose a method to prepare paranitrobenzene in 3 steps. Paranitrobenzoic acid, benzene, Friedel-Crafts alkylation, then nitrobenzene, and add potassium permanganate to oxidize CH3 to COOH. This structure is asking, this is just a Friedel-Crafts acylation. The structure is this, they were given 5 marks. And then the mechanism, you guys know the mechanism. This can come separately because this is stable. See, they were not asking about this thingy. But I have just written because I'm not feeling is not drawing them. Sometimes they would ask. Sometimes they were in past, they were given marks. So I would definitely draw these 3 structures. So just draw them. This time not inclusive to marking scheme, but that's all right. Since my students always having more than enough time. Okay, next little part is stability. Cyclohexene, standard hydrogenation enthalpy is minus 120. Triene supposed to be 3 times of that. But benzene is minus 208. So that the rest of the time become this, the rest of the energy become this stabilization energy of benzene. We did this energy diagrams and everything. See how lucky we are. We have the full knowledge. That's what I'm saying. When you guys are coming to me, only to me. You don't want anything else. You're gaining this full knowledge. Don't get wet. Okay. Save your body for the exam. Qualitative analysis of cations. Okay. I have put numbers. Q is there. Addition of DLHCl. There are 4 cations, okay? That is, this structure they were gone with group analysis. DLHCl, it can be any of these silver, lead, and mercury compounds. Get the filtrate, and this is the white color precipitation. Cool to room, heat it, colorless, cool back, white precipitate, definitely lead chloride, H2S, lead sulfide, potassium iodide, yellow lead iodide. Done with that. get the filtrate, acidic H2S group 2, black color, all those black are possible, and black sulfide, that you already had lead here too, so that can be lead sulfide also. Then same A3, they say same A3, so this is again same lead sulfide. Rest of the part is colorless, so group 3 stuff. Okay, ferric, chromic or aluminium. They say white gelatinous, so that's aluminium. Let's go to confirm. Sodium hydroxide, colorless, yeah. That is that then. Then adding H2S, that is group 4, white precipitate. White supposed to be the zinc one, so this is zinc white. Sodium hydroxide, zinc hydroxide, then addition of excess, that colorless solution. Oops. See, addition of excess colorless solution, they are saying everything. Then group 5, white color can be any of these. And then flame test, crimson red, strontium. So this is supposed to be strontium carbonate. How easy. No second thoughts even in this question. No second thoughts. A lead chloride, B A2 lead iodide, A3 lead sulfide, B1 aluminum hydroxide, B2 sodium aluminate, C1 zinc sulfide, C2 zinc hydroxide, D1 strontium carbonate. See how easy. Okay, then the second part. Give a reason to use ammonium hydroxide, ammonium chloride, white gelatinous precipitate. Okay, you guys know the answer, but let's write to the marking scheme. Ammonium hydroxide is added to get the precipitate group 3 cations, ferric, aluminium, and chromic. You have to write those. If hydroxide concentration is high, group 4 cations with high Ksp may get precipitated. Zinc 2 plus, manganese, cobalt, and nickel 2 pluses. Ammonium hydroxide is added to decrease hydroxide concentration by common ion effect. See how clear these answers. NH4 plus from NH4Cl makes the reaction favors to left according to Lesch-Chatelier's principle, so that OH minus concentration is less 2 marks. Therefore, Fe3 plus, aluminium 3 plus, and Cr3 plus can get precipitate, avoiding precipitation of zinc 2 plus, Mn2 plus, cobalt 2 plus, and nickel 2 plus in medium. Get this practice, have this practice. I want you guys to go with this practice. That's why I'm doing this little ahead of time. Like, otherwise I would wait little more time to do 2022, but I decided to go on next week for that. Okay, so this little question is given. That's again an easy question. Part B, 9B. Did I miss a page here? Oh, no, it's there. Okay. X has a mixture of X, which has aluminium sulfide and ferric sulfide. I'm going to get these masses, aluminium sulfide M1 grams, ferric sulfide M2 grams, and they are getting some sort of a M mass from X, heating with H2, and given that the whatever the precipitation mass. So this reaction occurs, ferrous sulfide with H2, ferric sulfide with H2 gives the iron and H2S. But still, aluminium sulfide is remaining here. H2 is getting away. Then they get another same M heated with the O2. Sulfur part is just getting away, leaving these two. That SO2 reacting with H2O2 makes H2SO4. And this is a reaction between SO2 and H2O2. That H2SO4 titrate with Cv of sodium hydroxide. How easy. Okay, mass of aluminium sulfide M1, mass of ferric sulfide M2. Divide each of these by the molar masses. Is the number of moles. So number of moles of ferric sulfide become M2 divided by 208. In that, see, you have 2 iron. So that number of moles of iron become twice of that. 2 M2 divided by 208. And that multiply with the molar mass of iron, that is 56. That 2 can get mass of iron. Then iron mass plus this Fe2S3. Iron mass plus Al2S3. Al2S3 I have taken as M1. M1 is, yeah, Al2S3. That together equals 0.824. Okay, I have the first equation there. For this, iron mass plus aluminium sulfide. Okay, I am there. I need another equation. Heating with oxygen, aluminium sulfide makes aluminium oxide. Ferric sulfide makes ferric oxide, releasing SO2. So that these SO2 absorbed in, reacting with H2O2, that I have given that reaction earlier, that H2, SO2 convert into H2SO4, that is reacting with sodium hydroxide. They were given the Cv of sodium hydroxide. Now I'm going to find out one connection between these two. Okay. So this number of moles of aluminium sulfide equals M1 divided by 150. 150 is the aluminium sulfide molar mass. SO2 taken from aluminium sulfide equals 3 times of that. 1:3. So multiply this by 3 and that is this. Same way. Number of moles of, we already written that. Ferric sulfide. Stoichiometry is SO2 to ferric sulfide is again 1:3 multiplied by 3. So you can get number of moles of SO2 from ferric sulfide, that is 3M2 divided by 208. Then let's find the moles. CV of sodium hydroxide 0.036. Divided by 2 is the H2SO4 number of moles. But H2SO4 SO2 equals 1:1. So that's same number of moles of SO2. That's supposed to be equals to SO2 came from aluminum sulfide. SO2 came from ferric sulfide. So that is this reaction. I am writing the first reaction again here. So A and B both reactions are here. M1 and M2. So let's sort them out. This reaction B multiplied by 50 is this. Then that minus A. M1 cancel off. So you can find M2 0.416 grams. From A you can find M1 0.6 grams. Then percentage total is this, and M1 is this, that is aluminum sulfide 59%. Only these two in the mixture, so the other part is 100 minus 59, 40%, 94. There. And the easy. Okay, the full answer. If the above titration is carried out using methyl orange, would there be change in Biret reading? Phenolphthalein, methyl orange. Not given marks for this, but I have written for your reference. No 2 marks. This is a strong acid, strong base titration. Drastic pH change is 3 to 11. Phenolphthalein, methyl orange pH range fall within 3 to 11. So it is not changing. All right, moving on to the last question. But I want you guys to be little, concentrate little, like being mindful, because you guys are still having issues with unit 14, which I do not expect. But still, how many weeks, Baba? 3. Oh, no, not 3. Today is 4th. 11th week, 18th week, 25th week. Then, not that's it. Yeah, then 3 more days. Okay. I know you guys gonna win. I know definitely this time my results gonna be better than last time. I don't worry. I wouldn't worry, so you wouldn't worry. Yeah, just have the confidence. If you did not meet me, how you would go? If you are going with me, how you would go? That's totally different. I can prove it actually. Following flow chart, industrial extraction of elements P1, P2, P3. Okay, this is an element starting from 3 reagents. What is the hint? P1. Ancestors were making this 1,000 years ago, that we know. It's from this resource book that they are saying even in ancient history they were making iron. So this is supposed to be iron. Then the second hint, how they say thing about P1 is used as a catalyst in M2. Where's this M2? M1, M2. Yeah, then the ion catalyst, that's supposed to be then ammonia production. P3 is used to manufacture explosives. P3, that's supposed to be nitric. I am going with some other, it's supposed to be number 2. Anyway, you can get this idea. So this is ammonia production. This is nitric, then this is supposed to be the nitric production. This is the ion production. Then this is A. We are just using to make iron liquefaction and fractional distillation to get nitrogen. Hydrocarbon cracking gives hydrogen, which is making ammonia that oxidized to make this nitric. Add water to make nitric acid. Yeah. So that these are the answers. That is easy. Some students do this. That's okay. I don't say no, unless otherwise you are having issues. If I want you guys to go like expecting these maximum marks, not lower marks. Okay, maximum marks. Maximum marks is 100 marks. Sorry, 150. To go for 150, this question is not suitable. But some are selecting already because they are like, inorganic is harder. They can reach even like 10, 20 marks. So they want to stick, even if it is giving like 75 marks, that's all right for them. So then this is okay. Give the common names of raw materials R1, R2, R3. So this coke, coal, iron ore, limestones. Fourth part, balance equations for R1 for process of M1. Acid reducing agent, iron. These 3 reactions are showing. Fifth one, identify R1 and R4 nitrogen and hydrogen. M1 is iron, then this iron production, these reactions, and M2 is ammonia, then ammonia production reactions. Last one is the nitric, so the nitric production reactions. Then P1, P2, P3, these users. I'm just reading. Okay, I'm showing these answers for you, okay? All the answers. Iron, alloy steel, building constructions, machinery, ammonia, fertilizers, nylon, to neutralize acidic components of petroleum refineries, to treat wastewater, refrigerant, avoid premature coagulation of rubber whatsoever, or whatever they are asking, okay? Not all, they are asking how many? 2 users they are asking. Then ammonia, M2 process would be favor high temperature. Using this, they want us to give the explanation using this spontaneity. M2 is ammonia. Ammonia production is exothermic. Delta H is negative. Also, gaseous molecules decreases. Entropy decreases. Delta G equals delta H minus T delta S. Temperature increasing, T delta S become more positive. Delta J become more positive. Spontaneity decreases. Would not favor by high temperature. Actually, this part I did yesterday. Okay, this part has gone with this photochemical smoke and water pollution. I'm writing the answer here again. Gaseous chemical pollutants, they are asking with the conditions photochemical smoke, NOx, or you can write NO or NO2, volatile hydrocarbons, volatile organic compounds, or VOC, sunlight or solar radiation, temperature below 150. Why photochemical smoke is lower in morning and evening? Last time they were asking why it is high in daytime. Now they're asking why lower in morning and evening. The intensity of solar radiation is low during morning and evening. Therefore, photochemical smoke is weaker in morning and evening. How ozone is formed in lower atmosphere? NO2, NO2, that NO gives atomic oxygen, with atomic oxygen O2 gives ozone. 4 major products in photochemical smoke except ozone: peroxyacetyl nitrate, peroxybenzyl nitrate, short chain aldehydes, and dust particles or whatsoever. Free radicals by photochemical smokes are all these: OH, RCO, ROO, RO, oxygen, and any of these free radicals are possible. Electric vehicles affects PCS, photochemical smoke. Electric vehicles do not release ingredients for photochemical smoke. Therefore, electric vehicles contribute for the reduction of photochemical smoke, or no contribution to the photochemical smoke. What are the environmental problems easing with electric vehicles other than photochemical smoke? Global warming and acid rains. Ship was there. That ship has all these sodium phosphate, nitric, and lead acetate harmful effects. These two reduce the dissolution of O2 level. Reduction of dissolved O2 level by eutrophication, phosphate and nitrates. Nitric increase acidity or decrease pH. Lead increase heavy metal level in seawater. Natural rubber, the repeating unit, they are asking you to draw that. Then how to prevent coagulation by adding ammonia solution. Compounds to coagulate ammonia. Any acidic forming, you can just write the action. H plus can neutralize the COO minus groups, making the surface of rubber particles neutral. Particles can then combine together and become a lumpy mass. How vulcanization carried out? Rubber is heated with 1 to 3% sulfur. Number 5, two substances increase efficiency of vulcanization: organic catalyst and catalytic promoters such as zinc oxide. 3 properties by polymer additives: increase flexibility, decrease flammability, increase mechanical and physical strength, decrease harmful effects of UV radiation. Okay, done with that. I guess I had this 2021 marking schemes, English medium. Okay, marking scheme, I'm going to start from here. This is the marking scheme. Everything is here. If you want to get even a little bit of a like just going through the marking scheme and to get something that you feel uneasy, you can go through this. In the meantime, I want you guys to post your, see, there are different alternative methods. I want you guys to post your, Baba, get ready to leave. Get ready to leave, don't waste time. You can post me your marks, okay? So you're not wasting your time. I guess, yes, yeah. Don't waste your time. Even your parents are home, ask them to feed you. Just to make sure using the full time only for this. Okay, that's all. Okay, see, they are lucky faces and defeat them. I want you guys to exceed them. Okay, bye. Take care, everybody.